So far, all the classes we talked about are standalone classes. They don't have any relationship with the other class. They may be creating other classes object, but they do not have any uh, interaction with other classes. Let's talk about inheritance, generalization versus specialization. In real life, objects are typically specialized version of other more general objects, like the term insect mentioned here describes the very general type of creature with numerous characteristics. Grasshoppers and bumblebees both are insects. They share the general characteristics of an insect. They have 6 feet, they have 3 parts in the body, and they cannot control the temperature, all these things. However, they have special characteristics of their own. Grasshoppers can jump, bumblebees can sting. You never expect the grasshoppers to sting, right? So they are specialized version of an insect. Like here, insect itself has some attributes and methods. Insects can generally walk. They have 6 feet. They have 3 body. And all these are shared by both bumblebee and grasshopper. But bumblebee has something that is specific to it. It can sting. It has a sting method and have a stinger attribute. Grasshopper possibly have a jump method that the bumblebee doesn't have. The relationship between a superclass and an inherited class is called an is-a relationship. So a grasshopper is an insect. A poodle is a dog. A car is a vehicle. A specialized object has all the characteristics of the general objects, plus additional characteristics that make it special. So in object-oriented programming, inheritance is used to create a is-a relationship. Back to bumblebee and the grasshopper. Bumblebee is an insect. A grasshopper is an insect. In this case, we said bumblebee inherits the insect class, and the grasshopper inherits the insect class. Both inherits the insect class. We can extend the capability of a class. Inheritance involves a superclass and a subclass. Superclass is the general class, like insect, and the subclass is the specialized class, like bumblebee or grasshopper. The subclass is based on the superclass, or we call it extended from the superclass. Superclass are also called base class, and subclass are also called derived class. The relationship of class can be thought of as a parent and a child. Insect is the parent, grasshopper is the child, like a pet is a class, is a parent, dog is a child. And in the inheritance, the subclass inherits fields and methods from the superclass without any of them being rewritten. A new fields and methods may be added. We use the Java keyword extends in the class header to define subclass. Like here, public class final exam extends graded activity. That means final class is a graded activity. That's inheritance. Final exam inherits graded activity. But in Java, we use the keyword extends. We do not have anything like inherits, right? Okay, remember this, extends. Let's give an example of the graded activity. Graded activity, of course, have a grade, which is double, a score. Then you have the setter and getter. And you can also get grade that is A, B, C, D, E, F, A, B, C, D, F. Final exam inherits all these, the score, the set, get, and get grade. In addition, it also have its own attributes. Number missed, number questions, points of each, final exam constructor, and get points, get number missed. It contains all these attributes and methods that are specific to the final exam class. It inherits all non-private attributes and methods from the graded activity class. So let's bring up the graded activity Java. We have a public class graded activity, and we also have a final exam extends graded activity. So graded activity has score, set score, get grade. All these we have seen before. Final exam also have its own private attributes and its constructor, as well as the get points, its own methods. So in the final exam demo.java is actually a main where you have the final exam. You create a new final exam. And then you can see exam has a get points each, which is it's a private. The final exams get private method, public method. Whereas final exam can also have a get score and get grade method, which is not from the final exam Java, but from the graded activity Java, get score and get grade. We never define get grade and get score in final exam, right? However, you can call get grade and get score here with this exam object. The reason is final exam extends or inherits from the graded activity. Final exam extends from graded activity. So the extension makes it possible that final exam object can also access graded activities method, can use the same method as the other graded activity. And here you do not need to specify graded activity because once you specify it's a final exam, Java virtual machine knows that it's a derived class from graded activity. Oops. Members of the superclass that are marked private are not inherited by the subclass. Exists in memory when the object is subclass is created. So it's there and may only be accessed from a subclass by public method of the superclass. And this is something that some students have a hard time with. Remember, superclass is still a different class. So the private member of that superclass is still not accessible, even from subclass. However, you can use the public method of the superclass to read or write, to set or get. And this is also based on the idea of encapsulation, because when you create a class, you never know who is going to extend your class. So you need to encapsulate your data and your logic. And whoever wants to extend your class, they need to use your setter and getter so that they will respect your logic. They will still use your logic instead of writing their own logic to manipulate the data. That's the idea of encapsulation. So members of the superclass that are marked public are inherited and may be directly accessed from the class. When the instance of a subclass is created, the non-private method of a superclass are available through the subclass object, like what we see before, the exam, final exam object. You can set score, you can get grade, because final exam extends from the graded activity, although all these are not defined in final exam, but in graded activity. Non-private method and fields of the superclass are available in the subclass. Constructors are not inherited. That's one thing about constructors. Constructors are not inherited. When the subclass is instantiated, the superclass default constructor is executed first. And it doesn't Yeah. And let's bring up superclass and the subclass. Let me close this graded activity first. And we will bring up superclass 1, which is simple as that. There is a default superclass and there is a subclass. Now, when you create a subclass, you will by default running the superclass's default constructor. So you will only see, okay, let me bring this up. Constructor. When the subclass is instantiated, the superclass default constructor is executed first. All right. So when you have this constructor demo, when you create a subclass object, what will happen? The default constructor or the non-arg constructor will be executed first. That's why you see the superclass. You are creating, remember, you are creating a new subclass you are creating a new subclass 1 object, right? In subclass 1's constructor, it's only printing this is the subclass constructor. But you can see superclass constructor is also executed because subclass extends superclass. In order to create a subclass, you need to create a superclass first. The order is given that superclass has its own field and method. So you need to allocate memory space for superclass first before you can add another memory block for the subclass's fields and methods. That's why you see this here, that you are running a non-arg constructor followed by subclass, although you never explicitly call the constructor. The superclass constructor can be explicitly called from the subclass by using the super keyword. The super keyword refers to an object's subclass. The example is here. Let me close this demo 1 and open up demo 2. So again, we have subclass 2, superclass 2 with a constructor with an integer argument. Subclass 2 extends superclass 2, and in its constructor, in subclass's constructor, it explicitly calls the constructor of superclass 2. And here, one thing to note, super is a keyword, it's a Java keyword. It does not matter what the parent class is called. In our textbook, this class happens to be superclass. So there were some, in previous class, there were some confusion. Students thought that we call this super because the parent is called superclass, has a super in it. No, this is not the case. Super is a Java class. You can call this superclass like a super duper class or duper class or just a parent class. Has nothing, has no word super in it. Still, you will use this super keyword to call a parent class's constructor. So when you run this subclass 2 constructor, it's first calling the superclass constructor, of course, because super constructor is called first, right? Then it's calling subclass constructor. If a parameter constructor is defined in a superclass, the superclass must provide a non-arg constructor, or subclass must provide a constructor and the call superclass constructor. Basically, what it says is there should be no confusion. If there is a constructor defined in superclass that with parameter, then either you also have a non-arg constructor, or subclass must always call the superclass constructor in the constructor. So if subclass does not call a constructor, it will call a default constructor, non-arg constructor, right? That's why you always need to provide one. Calls to the superclass constructor must be the first Java statement. Again, this comes back to the same point that we covered before. You need to create the superclass first before you can create a subclass. You need to allocate the memory space for superclass first before you can add additional memory space for the additional fields and methods of the subclass. And back to this topic. So I think it's not really clear on why this is happening. But if you think about a subclass, there are just two options. Either all constructors, all subclass constructor explicitly calls a superclass constructor. In this case, everything is explicitly called, there's no problem. Or one subclass constructor calls one or more has no reference to super constructor, right? Then in this case, either superclass has a non-arg constructor because subclass constructor has no reference to super constructor. Then superclass has a no arg constructor. The subclass constructor will call a no arg constructor, or superclass has no arg constructor. Here, it will call a no arg constructor. It will call a no arg constructor. So if the superclass has a non-arg constructor, works. Otherwise, it will fail. Okay, so this is all this parameter is, this paragraph is about.